let us understand the types of forces acting in nut and bolt arrangement. If we observe the diagram, here is the bolt which is having external threads, and this is the nut which is having internal threads. This nut is in contact with washer on both the sides, and the washer is in contact with tube. I have shown with the help of the red marker. Now how these forces are acting. So what is happening when we tied the nut on this bolt? So we will show the direction of movement. So direction of movement of this nut is towards the tube. So I will show here the direction. Now we will consider the nut is applied the force P while moving towards the tube. So we will say that magnitude of force is equal to P, and this magnitude of force P is acting towards the tube. But this nut is in contact with washer. So this force P is transferred to the washer, and from washer it is transferred to the tube. So we can say that for tube there is compressive force. So I will write here tube, it is compressive force and magnitude is equal to P. Now when the compressive force is acting on the tube, then the force with equal magnitude but opposite direction is applied by this tube. Now this tube is in contact with washer. So this force is transferred to the washer. So I will show here the direction of force that is applied by the tube. So force with same magnitude, that is force P, is getting applied by the tube on the washer. Then this force P is getting transferred from washer to the nut, and this nut is in contact with bolt, and therefore finally this force P is getting transferred to the bolt. So direction will remain same, that is the outward direction. So I will show here the direction of this force. So magnitude will be same. So we can say that for bolt it is tensile force. For bolt it is tensile force acting, and it is equal to same magnitude, that is equal to P. So from this arrangement we can say that force in bolt, that is tensile force, is equal to force in tube, that is compressive force. So PB is equal to PT. So this is the first formula that we have to use for calculation. Now we know that we have to rotate the nut on the bolt. So how to find out the movement of the nut delta? Now if we observe, when we rotate the nut on the bolt, that means when we tied this nut, then there is the compressive force in the tube, and that time there is the contraction in length of this tube. So I will show here this contraction. So that is delta T. So this is the change in length, that is this tube length is getting contracted. So this space is available, and at the same time there is extension in the length of the bolt because of this tensile force. So I will show here this change in length. So this length is getting extended, and that is equal to delta B. Now if we observe, this is the space available due to contraction, and this is the space available due to extension. So these two spaces available for the nut, and therefore movement of the nut delta is equal to delta T plus delta B. Now this delta T is due to compressive force. But here we have to use the absolute values, that means we have to use the positive magnitude. So we can say that delta is equal to absolute delta T plus absolute delta B. So this is the second formula we have to use for the calculation. Now next, distance between two successive or consecutive threads is equal to pitch. So if we observe, these are the threads and the distance in between two successive threads is known as pitch. Linear distance travelled by knot is equal to pitch multiplied by number of turns. Given question, nut is tightened up on the tube through rigid end blocks until tensile force in bolt is equal to 40 kN. External load 15 kN applied to the end blocks tending to pull them apart. Calculate resulting force in the bolt and sleeve. Let us understand given question. There are two types of loads acting in nut and bolt arrangement. First type is the tensile force in the bolt and is equal to 40 kN. So we will show here, this is the bolt and the tensile force is acting. And second type is the external load on the end blocks, which is equal to 15 kN tending to pull them apart. So these two are the end blocks and the type of load is tending to pull them apart. That means direction is outward direction. So we can say that this 50 kN force is also a tensile force. So this is the second type of force. Now, due to these two types of forces acting in this nut and bolt arrangement, we have to find out the resulting force in the bolt and resulting force in the sleeve or tube. Now we have formula. Stress sigma is equal to force divided by cross sectional area. So if I write this, sigma is equal to P by A. So we have to first find out the sigma due to this tensile force in this bolt as well as in this tube. So we will give here the suffix 1 for the first type of force. So I will say that sigma bolt 1 we have to find out, and then sigma tube 1 we have to find out. Due to this, tensile force is equal to 40 kN. Now in the same way we have to calculate the stress due to external load on the end blocks. So we will give here the suffix 2. So we will calculate sigma bolt 2 and sigma tube 2. Now to find out the resulting force, we have to first calculate the resulting stress. So how to calculate resulting stress? That is sigma R is equal to, so sigma R for bolt is equal to sigma bolt 1 plus sigma bolt 2, and resulting stress in the tube is equal to sigma R tube is equal to sigma tube 1 plus sigma tube 2. So these four parameters we have to calculate first. So how to calculate this? So we will concentrate on the tensile force in the bolt. So here is the bolt. So tensile force in the bolt, that is equal to compressive force in the tube. So this is the condition for this tube and or this bolt and nut arrangement. So we have to use this condition. So we will first calculate the cross sectional area. So cross sectional area for bolt. So if we observe, the bolt diameter is 20 mm. So we have to use standard unit meter, and we have formula pi by 4 d square. So when we use this formula, then we will get 3.14 into 10 raised to minus 4 meters square. Now in the same way we will calculate cross sectional area of this sleeve or tube. So it is equal to pi by 4 multiplied by outer diameter square minus inner diameter square. Now this diameter also we have to take into meter. So it is given in millimeter. So when we calculate, we will get 8.63 into 10 raised to minus 4 meter square. Now this is the cross sectional area of bolt and tube. Now we have to calculate stress. So how to calculate this? So we have tensile force, that is we have P bolt, and P bolt is equal to P tube. So tensile force in bolt is equal to compressive force in tube and is equal to 40 into 10 raised to 3 Newton, because we have to use standard unit, that is Newton. So we can write this P in terms of sigma and A, that is sigma bolt multiplied by A cross sectional area of bolt is equal to sigma tube multiplied by cross sectional area of tube. So when we put the values, and it is equal to 40 into 10 raised to 3. Therefore, we can calculate these two unknown terms, that is sigma bolt. Now this time we have used this first load. So we will write here sigma bolt 1 is equal to 12.7 into 10 raised to 7 Newton per meter square, and sigma tube 1 is equal to 4.63 into 10 raised to 7 Newton per meter square. Now these two values are important. Now we will calculate sigma bolt 2 and sigma tube 2 by using external load on end blocks is equal to 15 kilonewton. Now we will move to the second type of load, that is the tensile load, which is equal to 15 kilonewton acting on the end blocks. If we observe, this bolt as well as this sleeve or tube are fastened together. So when they are fastened together, so we can say that it will act like a compound ties or struts. So there are two conditions. First condition, the total load is shared by the load in the bolt as well as load in the tube. So we can say that total load P is equal to P bolt plus P tube. So this is the first condition. And second condition, strain produced in bolt is equal to strain produced in the sleeve or tube. But if we observe, the length of this bolt and length of the tube is given different. So for the different length, instead of strain, we can say that elongation or contraction will be same. That means change in length delta L in the bolt is equal to change in length delta L in the tube. So these two conditions we are going to use, and we will find out the stress in the bolt and stress in the tube. So first condition, total load P, that is 15 into 10 raised to 3 Newton is equal to P in the bolt plus P in the tube. So what is the reason behind that? Because these two types, this bolt and this tube, are fastened together, and when they are fastened together, and then the tensile force is acting on them. So how we can define this P bolt? That is equal to sigma bolt multiplied by area, that is cross sectional area of bolt, plus sigma tube multiplied by area of tube. Now area of bolt and area of tube we have calculated, and we will put the value. So we will get this equation in terms of sigma tube and sigma bolt, and we will give here, this is the equation number 1. Now we will move to the second condition. So change in length, that is delta L in the bolt is equal to change in length delta L in the tube. So how we can define this delta L? So we know the Young's modulus. Young's modulus E is equal to, we can say that stress by strain, that is sigma divided by strain rho. So we can say that delta L, so strain is equal to, I will write here delta L divided by L. So how we can define this? So I will write here sigma multiplied by L by delta L. So delta L is equal to sigma L divided by E. So delta L in the bolt, we will write sigma bolt multiplied by length of the bolt divided by E of the bolt, that is Young's modulus of the bolt, is equal to sigma tube multiplied by length of the tube divided by E of the tube. But if we observe, for bolt and sleeve same material is used, and therefore for same material this E will be same, and therefore it is cancelled on both the sides. So sigma bolt multiplied by length of the bolt. So length of the bolt is standard unit is meter, that is 0.5 meter, is equal to sigma tube into length of the tube is 0.4 meter. So when we simplify this, then we will get the relation sigma bolt is equal to 0.8 sigma tube. So this is the second equation. Now when we put sigma bolt is equal to 0.8 sigma tube, then we can solve this first equation and we will get the value of stress in the tube. And then we can calculate the value of stress in the bolt. Now it is due to the second type of load. That means we can say that we will get the value sigma tube 2 and sigma bolt 2. Calculated values of stress are stress in tube due to second type of load 1.34 into 10 raised to 7 Newton per meter square, and stress in bolt 1.077 into 10 raised to 7 Newton per meter square. Now we have to calculate resultant stress. So resultant stress in the bolt is equal to resultant stress, that means we have to add these two values of the stress in the bolt, that is sigma bolt 1 plus sigma bolt 2. Then resultant stress in the tube is equal to sigma tube 1 plus sigma tube 2. Now if we observe in the first type of force, tensile force in the bolt is acting. So when the tensile force in the bolt is acting, that time compressive force in the tube is acting. So stress developed in the bolt is tensile. So I will write here for the first type, stress developed is tensile due to tensile force, and stress developed in the tube is compressive due to compressive force. So sigma tube 1 is compressive. This is because of the first type of the load. So we will move to the second type. So second type is the tensile force is equal to 15 kilonewton, and it is applied because bolt and tube are fastened together. So when they are fastened together, then on the bolt as well as on the tube, tensile force is acting. So stress developed in this bolt as well as tube due to this second type of load is tensile. So I will write here as a tensile. Now it is important to calculate this. So for the tensile force we will give the positive magnitude, and for compressive force or stress we will give the negative magnitude. So here for bolt 1 it is 12.7 into 10 raised to 7 plus sigma bolt 2, it is 1.34 into 10 raised to 7. Now in the same way sigma tube 1, so it is compressive, so I will write minus 4.63 into 10 raised to 7 plus sigma tube 2, it is 1.077 into 10 raised to 7. We will get the answer sigma r bolt is equal to 14.04 into 10 raised to 7 Newton per meter square. So it is having positive magnitude, so type of the stress is tensile stress. Now how to calculate the resulting force in the bolt? So the stress multiplied by cross sectional area. So when we multiply it with cross sectional area of bolt, then we will get answer 44 kilonewton. So in calculator we will get answer in Newton, but we will convert it into kilonewton, and the type of force is tensile because magnitude is positive. Now we will calculate the sigma r tube. So when we calculate these values, then we will get the negative answer, that is minus 3.55 into 10 raised to 7 Newton per meter square. So whenever there is negative magnitude for the stress, that means nature of the stress is compressive. So how to calculate the resulting force? That is this magnitude multiplied by cross sectional area of the tube, and it is equal to 30.63 kilonewton, and in bracket we have to write the nature of the resulting force. So for bolt it is tensile force, and for tube it is compressive nature.